programming concept, object-oriented programming concept. Generally, simply we are calling as a OOP, object-oriented programming. Object-oriented programming concept. Observing very clearly, OOP is a programming approach where we organize the program around the objects and the classes rather than the functions and procedures. In previously in core Python, we'll discussing about functions concept. Okay, and the procedures. In place of functions and procedures, here we are using objects and classes. Okay, here using or organize the program, organize a program using objects and the classes rather than rather than which one? Only functions and procedures. Only functions and procedures. Okay, organize a program using objects and classes rather than only functions and procedures. Okay, Python supporting OOPS concept. Python supporting OOPS concepts. Okay, Python supporting OOPS concept. Python strongly supporting OOPS concepts and providing the features like as a class, object, providing the features. The OOPS concepts are like class, object, object, and encapsulation, encapsulation, inheritance, inheritance, polymorphism, polymorphism, abstraction. These are the main OOPS principles. Okay, these four concepts simply we are calling as a four pillars of object-oriented programming. If we want to implement these concepts practically, we need to require one structure. That structure is nothing but a class that is called one blueprint. Okay, if you want to create, that means if you want to access the properties of that class, we need to create an object. Object is nothing but a physical existence of a class. Physical existence of a class. Are you clear? These are the OOPS concepts. Class, object, encapsulation, inheritance, polymorphism, and abstraction. Okay, these four concepts we'll discussing about four pillars of object-oriented programming. Object-oriented programming. Why do you need to OOPS concept? Why need OOP programming? Why need OOP programming? Observing very clearly, if you want to developing an application, if you want to developing an application without OOP programming, okay, for suppose I want to develop the student management application. Suppose we are developing student management application or system without without OOP programming. Okay, how to store that application? For example, student one student one name is equal to Shiva. Student one having age, student A one age, student one course like Python. Second student data I want to manage. Okay, student for suppose three students, four students, student two. Okay, without programming, observing very clearly. Student three. For suppose if you want to maintain the 100 students, 100 times we need to declare these variables. 100 into every student key data parameters. That means 100 into 3, 300 variables we are declaring, observing very clearly. Okay. Not only this one, we can take student 5, student 6, student 7, 100 students. Okay, every student having three data parameters. Now simply 100 into 3, 300 variables we are declaring in our program. Without OOP concept, this is the problem. Okay, observing very clearly as the application grows, managing the hundreds or thousands of students, it's become difficult. With the OOP, we can create a student class. With the OOP, we are creating a student class for suppose observing very clearly. Here I'm writing one Python code. Okay. Next, another student I am taking. Like as a student 5, just for understanding purpose, why we need OOP concept, just wait. After completion of this example, we will get more clarity. Okay, student 5, I am taken as a Virat. Dhoni, Java, Pant, SQL, Gill, Python. Okay. If you want to print, if you want to print this student data, how to print that one? Print F string, formatted string, name, student one name. Okay. Slash T, age, student one age, slash T, course, course, student one course. Just wait. After executing this program and the OOPS concept program, after that we will get more clarity. Okay. student 5, student 6, student 7, okay. Next one, student 8. Now simply procedure oriented programming, POP. Example, this is a procedure oriented. Okay, same program I am trying to implement it in whoops concept. In whoops concept. In Python, okay, with whoops concept, we need to create a class. We need to create a class. Class, like as a class name as a student. Okay, if you are creating a class by using class keyword, later we are explaining. Okay, just we are comparing this code and this code. Okay, now we are declaring the initializer. It takes the self as a default parameter. Name is required. Age is required. Course value is required. Course value is required. Now here self dot name, we are assigning the name. Self dot age, we are assigning the age. Self dot course, we are assigning the course. Next one, def student underscore info. Student underscore info. Now here I want to print this information like here name, self dot name, age, self dot age, and course, self dot course, self dot course. Okay, just observing. Now I want to creating an instance or object. Okay, student one, S1 equal to student class instance. At the time of creating an instance, this name is course we are passing. Similarly, here, which data we are using, name Shiva, age 34, Python. Next one, S1 dot student underscore info. That method we are calling. Next, second student data I am created. Student, student data here, Rama 35, Rama 35 Java. S2 dot student underscore info. Okay, next S3 equal to student, third student. Just a comparison. Same input is not a mandatory. We can take anything. Krishna 29 and SQL. S3 dot student underscore info. Student underscore info. Observing very clearly in the previous scenario for suppose three students data I am writing. Okay, up to this one. Okay, 8 students data. Okay, same logic we are implemented. 8 student instances we are created. For suppose in the procedure oriented, now here 3 students data is enough. Okay, whenever we are writing the long code, then only we are easily understanding between the procedure oriented and the object oriented. This is a procedure oriented fashion, and this is a object oriented fashion. Object oriented fashion. Whoop. Okay, now same output we are getting. Name, age, course. This is an okay. Totally okay. Totally 12 lines of code we are writing. Here also you are implemented 15 lines of code. But in the longest program, we are getting the differences. We are getting the differences. Okay. In the previously, every student data we are declaring number of times, but here we are declaring the variables only one time. But whenever we are calling that one, we are allocating the memory. We are allocating the memory. Now here each student is an object. Student 1 is an object, student 2 is an object, student 3 is an object. Okay. And each object containing its own data. Student 1 having own data, student 2 having own data. Okay, in this scenario, okay, this is a class. This is called blueprint. If we want to access the data members of this class from outside the class, we need to creating an objects. Now, physical existence of a class is nothing but an object. Now, student S1 is object, S2 is an object, S3 is an object. Every object having its own data. Are you clear? Okay. Are you clear why we are using OOPS programming? Okay. In the real life example, thinking about a car having some properties or data, like as a brand, model, color, price, and the speed. For example, observing very clearly a class having two things, properties and behavior, or data and actions. This is a class. Okay. Car class, car having some properties like as a brand, model, next car color, next one price, speed. Okay. And we are performing some actions, car having some behavior like as a start, stop, brake, accelerate, accelerate. Okay. These are called properties. In generally, we are calling as a properties. In the programming scenario, this is called data. This is called data. And in generally, this is called behavior. Behavior, or we are calling as a actions. We are calling as an actions. Or some people in the programming environment, we are calling as a methods. We are calling as a methods. Methods. Okay. Car having car class having class name. Here the class name. This is a class name. This is a class name. Here class name is a car. That car having some properties or data members or member functions. These are called member functions. Okay. Are you clear? Next one, we need to understand what is meant by class. A class is a blueprint or a template for creating an object. A class is a blueprint or template for creating an object. For creating an object. Okay. For example, if we want to build one new house, what will happen immediately? Go to civil engineer and to get one plan. That plan is nothing but a blueprint that is called class. By using that plan, we are implementing same type of houses. Number of houses we are creating, either one house we are created, or two house we are created, or three house we are created. That physical existence of house we are calling as a object. Okay, observing very clearly. Think of a class as a building plan. Building plan. Class is nothing but a blueprint. We are implemented original or actual, that is called object. That is called object. The physical existence of a class is nothing but an object. Technically, object means object is an instance of a class. Object is an instance of a class. Observing very clearly, here we are creating an object. This object is a which one? Instance of this particular student class. Okay, we are creating n number of instances to this particular class. We are creating n number of instances to this particular class. Every instance having one unique address. Every instance having one unique address. Okay, later we'll discussing what is init and what is a student info. These are called methods and these are called variables. Later we'll discuss it. Okay, object is a instance of a class. Instance of a class. Here student is a class and S1 is an object. S2 is an object. Which object? Student class objects. Student class objects. Are you clear? Okay, simply this is called initializer. Okay, or constructor. Initializer or constructor. Initialize the object data. The initializer is used to initializing the object data. Initializing the object data. Are you clear? Okay, whenever we are executing this statement internally, this one is executed. This is Shiva is passing to this parameter name, and this 34 is passing to this age, and this Python is passing to course. These values we are allocating here. Okay, at the same time, here one parameter we are using that is called self. Self is also one type of reference variable which is pointing to current class object, which is pointing to current class object. Self is represented. For suppose with respect to this one, self is represented S1. Self is represented S1. With respect to this one, self is represented for S2. With respect to this one, self is represented for S3. S3. Okay. Next one, this is called method. It is similar to like as a function. It is similar to like as a function. Already in core Python, we will discussing about functions concept. If we are creating a functions and method, same keyword we are using that is called def keyword. But outside the class, we are declaring that is nothing but a function. And inside the class, we are calling as a method. We can define a function inside the class that is called method. That is called method. Whenever we are calling this method with respect to which object S1, now we will get the S1 data. With respect to S2, we are calling this method at that time second student information we are getting. Okay, are you clear? This is about class and object. Class is a blueprint and the object is a physical existence of that class or instance of a class. Class is a blueprint and the object is a instance of a class. Instance of a class. Are you clear these two topics? Class and object. Next one, these are the four pillars of object-oriented programming concept. If we want to implement these concepts practically, we need to require these two things. That's why first we need to discussing class and object. Okay, here what is meant by encapsulation? Okay, this is an introduction class, like as a overview of OOPS concepts. Okay, now encapsulation. Next class we'll discussing each and every topic in detail with a number of examples. Encapsulation. Encapsulation means bundling of data members along with the functions inside a class, inside the class. That is nothing but an encapsulation. Encapsulation means bundling of data members along with its functionalities inside a class. That is nothing but a encapsulation concept. Encapsulation concept. Okay. Next one, we are discussing about inheritance. Inheritance means we are acquiring the properties from one class to another class. We are acquiring the properties from one class to another class. We are acquiring the properties from one class to another class. Properties means our data members under methods. Properties under methods. For example, we can take in as a vehicle class. Okay, we are extending the properties from vehicle class to car class and vehicle class to bike class and vehicle class to bus class. Okay, car and bike can inherit common functionality from the vehicle class. For example, we are taking the children's and parents. The children's take the properties from parent classes, parent. Okay, next one we'll discussing about different type of inheritances are there, single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. Now we'll discussing about polymorphism. Okay, polymorphism means many forms. The same interface or method name can behave differently depending on the object, depending on the object. For example, if you are using length function, okay, length function depends upon the parameter. We are passing string object. In that case, it gives number of characters. We are passing list object. It gives the number of elements. If you are passing the dictionary object, it gives the number of items. Number of items. Okay, that is nothing but a polymorphism. The same interface or method name can behave differently depending on the object. For example, we are taking the two classes like as a dog class and cat class. In these two classes, we are declaring the same method like as a sound method. But whenever we are calling sound method with the help of dog class instance, we will get one sound like as a bow bow. We are calling same sound method with the help of cat class reference. Okay, at that time we will get different sound like as a meow meow. That means same method name, but it works differently Or that method behave differently depends on the object type. That is nothing but a polymorphism concept. Polymorphism means the same interface or method name can behave differently depending on the object. Next one, observing very clearly, abstraction. Okay, here a different type of polymorphism is there, runtime polymorphism or method overriding. In generally, compile time polymorphism is there, but in Python there is no compile time polymorphism. Here only runtime polymorphism will discussing. That runtime polymorphism example like as a method overriding concept. Next one, abstraction. What is the meaning of abstraction? Abstraction means hiding the unnecessary implementation details and exposing only the essential functionality. Essential functionality. Abstraction means hiding unnecessary implementation details and exposing only the essential functionality. In the real life example, for example, if you want to go to ATM machine, I want to withdraw some money. What will happen? Go to nearest ATM center, insert your card, enter the PIN number, and enter how much amount is required. That amount we are enter. Okay. Now the machine calculated internally and dispense some amount of money. Okay. Observing very clearly, the abstraction means hiding the unnecessary details or unnecessary information. That means internally what will happen whenever we are inserting the code, whenever we are enter the PIN number, okay, whenever we are enter the required amount, internally what will happen? You don't require. As a user, we don't require. Simply to hide that concept and it shows the user what is the necessary information, that information we are providing. That is the concept called abstraction concept. Abstraction means hiding the unnecessary implementation details and exposing only the essential functionalities. Okay, that is called abstraction concept. Abstraction concept. Are you clear? Okay, this is about just the overview of OOPS concept. What is OOPS programming? Why we are using OOPS programming? And what are the whoops concepts are there? What are the whoops concepts are there? Okay, why we are using whoops concept? Why we are using whoops concepts are benefits of whoops concepts. Whoops is particularly useful for large application because it providing the reusability. Okay, benefits of whoops. Benefits of whoops. Reusability. Reusability. Okay, we can reuse the classes and the methods. Maintainability. 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 Code can be divided into logical components and it is providing security. Security. Okay, encapsulation helps control access to internal data. Next one, scalability. 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 Large applications can be organized into classes and objects. Next one, flexibility. Flexibility. These are the benefits of OOPS concepts. Inheritance and polymorphism make it easier to extend the functionality. Inheritance and polymorphism make it easier to extend the functionality. Okay. Next one, real world modeling. Real world entities can be represented naturally. This is about benefits of OOP programming. Benefits of OOP programming. Are you clear? Now simply observing very clearly, Okay, observing very clearly. OOP object-oriented programming help us write the clean, reusable and maintainable code by organizing it around the real world entities. Real world entities. This is the OOP's benefits: code reusability, organization, maintainability, scalability, flexibility, and real world modeling. Okay, code reusability means write once, use many times. Better organization. Code is organized into classes and objects. Next one, easier maintenance. Changes in one part don't affect the whole program. Scalability, easy to extend and add the new features. Real world modeling, maps the real world entity to code. These are the key concepts of OOPS class. That is a blueprint or template for creating the objects. Object means that is an instance of a class. Encapsulation, bundling of data and the methods. Abstraction, hiding the unnecessary details. Inheritance, reusing the properties of parent class. Polymorphism, one interface, many forms. Okay, what is a class? A class is a blueprint or a template used to create an objects. It define the properties like as a variables and the behaviors like as a methods that the object of this class will have. Here observing very clearly. I am taken as a one class properties, brand, model, and year. And this is the methods, info and the start. Info and start are methods are function that define the behavior. Here init is a special method like as a constructor used to initializing the object data. What is an object? An object is an instance of a class. When a class is defined, no memory is allocated. When object is created, then only memory is allocated and we can access the data and the methods. Okay, this is a live example. Car blueprint under oops class car. Okay, this is a red car and a car one is the red object. That is a blue car. Okay, that is a second object. Okay, previously we are taking as a student class. Now we are creating an object S1. That is a one student object. S2, that is another student object. Similarly here, this is the real world example and this is the whoops concept. Okay, class is a blueprint. Object is a real entity created from the class. Use class to define object to use. This make code modular, reusable, and easy to manage. Easy to manage. Okay, are you clear? Today we'll discussing about the overview of OOPS concept. What is OOP programming? Why we need to learn OOP programming? What are the benefits of OOPS programming? What are the OOPS concepts are there? Okay, class, object, and encapsulation, inheritance, polymorphism, data abstraction. Are you clear? From next class onwards, we'll